ground fault circuit interrupter, or GFCI, receptacle serving an air handler unit can be located in a room adjacent to the room housing the air handler unit. The critical factor determining the acceptability of this placement is the distance between the GFCI receptacle and the air handler unit. In this specific scenario, the air handler unit is situated a total of 18 feet from the GFCI receptacle. Therefore, it is essential to consult the relevant electrical codes and standards to ascertain whether this distance complies with the applicable regulations. The National Electrical Code, commonly referred to as the NEC, provides comprehensive guidelines and requirements for electrical installations, including the placement of GFCI receptacles in relation to specific equipment. It is imperative to review the NEC to determine if any restrictions or limitations exist regarding the distance between a GFCI receptacle and an air handler unit. These regulations are in place to ensure the safety and proper functioning of electrical systems, preventing potential hazards such as electrical shocks or equipment damage. The NEC outlines various requirements for GFCI protection in different locations and applications. These requirements are based on the potential risks associated with each environment, such as exposure to moisture or proximity to grounded surfaces. For instance, GFCI protection is commonly required in bathrooms, kitchens, and outdoor areas where the risk of electrical shock is higher. When determining the permissible distance between a GFCI receptacle and an air handler unit, it is crucial to consider the specific requirements outlined in the NEC for the location where the air handler unit is installed. The NEC may specify a maximum distance that the GFCI receptacle can be located from the equipment it serves. This distance limitation is intended to ensure that the GFCI device can effectively detect and interrupt ground faults, providing adequate protection against electrical hazards. If the distance between the GFCI receptacle and the air handler unit exceeds the maximum limit specified in the NEC, it may be necessary to relocate the receptacle or install an additional GFCI device closer to the air handler unit. Compliance with the NEC is essential to ensure the safety and proper functioning of electrical systems. Failure to adhere to these regulations can result in electrical shocks, equipment damage, or even fire hazards. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that electrical installations comply with the applicable codes and standards. In addition to the NEC, local electrical codes and regulations may also apply. These local codes may have additional requirements or restrictions that are not covered by the NEC. It is important to check with the local authorities to determine if any specific regulations govern the placement of GFCI receptacles in relation to air handler units in the area. Furthermore, the manufacturer's instructions for the air handler unit and the GFCI receptacle should also be consulted. These instructions may provide specific recommendations or requirements for the installation and placement of these devices. Adhering to the manufacturer's instructions is crucial to ensure the proper functioning and safety of the equipment. In summary, the permissibility of locating a GFCI receptacle in a room adjacent to the room housing an air handler unit depends on compliance with the NEC, local electrical codes, and the manufacturer's instructions. The distance between the GFCI receptacle and the air handler unit must be within the limits specified in these regulations to ensure adequate protection against electrical hazards. It is always recommended to consult with a qualified electrician or electrical inspector to ensure that electrical installations comply with the applicable codes and standards. They can assess the specific installation conditions and provide guidance on the proper placement of GFCI receptacles to ensure the safety and proper functioning of the electrical system. Additionally, understanding the fundamentals of ground fault circuit interrupters, or GFCIs, is essential for comprehending their role in electrical safety. A GFCI is a safety device designed to protect individuals from electrical shock by monitoring the electrical current flowing through a circuit. It works by detecting any imbalance between the outgoing and incoming current. In a properly functioning circuit, the current flowing out to the load should be equal to the current returning. However, if a ground fault occurs, meaning that the current is leaking to ground through an unintended path, such as a person touching a live wire, the GFCI will detect this imbalance. When the GFCI detects a ground fault, it quickly interrupts the circuit, typically within milliseconds, preventing a dangerous electrical shock. The threshold for tripping a GFCI is very low, typically around 5 mA, which is far below the level that can cause serious injury or death. GFCIs are commonly used in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. They are also required by electrical codes in certain applications, such as near swimming pools and hot tubs. There are two main types of GFCIs: receptacles and circuit breakers. GFCI receptacles are installed in place of standard electrical outlets and provide GFCI protection at that specific location. GFCI circuit breakers, on the other hand, are installed in the electrical panel and provide GFCI protection for the entire circuit. When selecting a GFCI, it is important to choose one that is suitable for the specific application. Factors to consider include the amperage rating of the circuit, the voltage of the electrical system, and the environmental conditions. It is also important to ensure that the GFCI is listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets safety standards. Proper installation of GFCIs is crucial for their effective operation. The installation should be performed by a qualified electrician in accordance with the manufacturer's instructions and all applicable electrical codes. It is also important to test GFCIs regularly to ensure that they are functioning properly. Most GFCIs have a test button that can be used to simulate a ground fault and verify that the device trips as expected. If a GFCI fails to trip when tested, it should be replaced immediately. In addition to GFCIs, other safety devices, such as arc fault circuit interrupters, or SIs, are also used to protect against electrical hazards. SIs are designed to detect and interrupt arc faults, which are dangerous electrical arcing conditions that can lead to fires. SIs are typically installed in the electrical panel and provide protection for the entire circuit. Understanding the principles of electrical safety is essential for preventing electrical accidents and injuries. Always follow safe electrical practices when working with electricity, and never attempt to repair or modify electrical systems unless you are a qualified electrician. If you are unsure about any aspect of electrical safety, consult with a qualified professional. Furthermore, consider the specific context of air handler unit installations. Air handler units often contain components that could potentially create ground faults, such as motors, heating elements, and control circuits. Therefore, GFCI protection is often required to protect individuals from electrical shock if a fault occurs within the air handler unit. The location of the GFCI receptacle serving the air handler unit is important because it must be readily accessible for testing and resetting. If the GFCI receptacle is located in a remote or difficult-to-reach location, it may be less likely to be tested regularly, and a potential ground fault could go undetected. In some cases, the electrical code may require the GFCI receptacle to be located within sight of the air handler unit. This requirement is intended to ensure that the GFCI receptacle is easily accessible and that any problems with the air handler unit can be quickly identified. However, the specific requirements for the location of the GFCI receptacle may vary depending on the jurisdiction and the specific application. Therefore, it is important to consult with a qualified electrician or electrical inspector to determine the applicable requirements in your area. In addition to the location of the GFCI receptacle, the wiring of the circuits serving the air handler unit is also important. The wiring must be properly sized and installed in accordance with the electrical code to ensure that it can safely carry the electrical current required by the air handler unit. The wiring must also be properly grounded to provide a path for fault current to flow back to the source, allowing the GFCI to detect and interrupt the circuit in the event of a ground fault. When installing or servicing an air handler unit, it is important to always disconnect the power to the unit before working on any electrical components. This will help to prevent electrical shock. It is also important to use proper personal protective equipment, such as insulated gloves and safety glasses, when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. In addition to the technical aspects of GFCI installation, it is also important to consider the practical implications of the location of the GFCI receptacle. For example, if the GFCI receptacle is located in a high-traffic area, it may be more likely to be accidentally tripped, which could interrupt the operation of the air handler unit. Therefore, it is important to choose a location for the GFCI receptacle that is both accessible and protected from accidental tripping. In some cases, it may be necessary to install a GFCI receptacle with a tamper-resistant cover to prevent unauthorized access or accidental tripping. These covers are designed to prevent children from inserting objects into the receptacle and also to protect the receptacle from damage. Another factor to consider is the aesthetics of the GFCI receptacle. In some cases, it may be desirable to choose a GFCI receptacle that matches the decor of the room. There are many different styles and colors of GFCI receptacles available, so it is possible to find one that blends in with the surroundings. However, it is important to ensure that the GFCI receptacle meets all applicable safety standards, regardless of its appearance. In conclusion, the placement of a GFCI receptacle for an air handler unit must comply with the National Electrical Code, local regulations, and manufacturer's instructions. The distance between the receptacle and the unit is a key factor. Always consult with qualified professionals for safe and code-compliant installations.